I don't say anything wrong, so it should be okay. All right. Hello, everybody. This is another day of us preparing problems in Polygon in order to eventually make a lecture on Gaussian elimination. Does everything work in Codeforces, or my stream already disappeared? Yeah, I think it is working. Cool stuff. What's this? Some very old comment. Sign up for Twitch to watch me live. Oh, cool. I mean, you don't need an account to watch me live, but you need one to comment. But there's also this, at the same time, there's stream to YouTube. Oh, and again, we would get echo. Yep. What we did last time was prepared second and third problem, I think, where we did binary version of Gaussian elimination. But somewhere in GitHub, we have the notes on what problems to prepare. These are the old notes. XOR maximization. I'm fine. Thanks, guys. So time to move to kind of fourth problem. Given small, maybe it's time to do this one. Given small directed graph, find EV of the number of moves. And there was a related CS Academy problem. Oh yeah, this one. And it's up to 50. I need to log in here using Facebook or Google. I have no idea. A common issue with authentication is that I don't remember if I used Google or Facebook to authenticate. All right, so submissions. No, I want my submissions. Are there some? Maybe this is not my account. I'm trying to see if there is something like account ID. Profile, no username yet. All right. So not my account. Need to log out. I'm not showing you just in case I'm revealing some data. So maybe Facebook. No. Okay, then I need to log in with like password and email address. Great. I can't get it right. Or maybe just their database is dead. Maybe. Can you take my problem at the end of the session? Not really. I'm not doing random problems today. Feel free to suggest it when I have a stream when I solve random Codeforces problems. Made an Amazon account and subscribed to Amazon Prime just to watch these streams? Well, too bad. I'm not taking any money from that. I mean, you cannot Prime subscribe to me. Anyway, I need to implement this. Not this, what I'm working, this one. and I need to investigate what happens with various graphs. So that's what we will do for the first hour of this stream. We'll implement here, like, what can be the solution. Yeah, actually, how do I check the correctness of my solution? I don't really see, but we will try to generate a graph where the answer is huge. So what kind of graph there needs to be so that when you start walking from vertex 1, it will take you a lot of time until you reach n. If graph is directed, then I think the best way to do is just to put a lot of edges backwards. So from every vertex v, there will be edges to vertices 1 through v minus 1, and also one edge forward. And then the expected time will be of magnitude n factorial. So this cannot work just because the answer is too big. And now the question is, what about modulo, right? Say something like, you can safely assume that the average number of spaces visited by a ball before hitting a target. I see that I was referring to some other problem. Will not exceed billion. Oh, this is from ICPC hard problem. So there was an ICPC problem where they guaranteed that. If the graph has special structure, we can do this faster. Japanese problem, damn it. I hate reading my notes from a year ago. Japanese problem, great. What's the Japanese problem? Wait, I don't remember. What do we have here in Gini? Occurrences. Oh yeah, this is from the previous stream, so that's all right. Japanese problem, too many people in a small area. You think this is what I was referring to? Maybe. How did you get problem B wrong with last test? See the comments below YouTube video about CodeGem. I refer to that there. 0. It was wrong to initialize something as 0, and then when looking at first character, I might have done something invalid. I might have made an invalid step, kind of. So even though solution was 0, my program printed something negative. That's in short. I think we had a directory for that, right? Code forces. No, not this. What directory then? YouTube? Wait. Maybe it was here. I did some codes already. Where are they? Code forces. No, Talent Division for Geometry, Google Hash Code, a Polish Olympiad, and other Polish contest, Petrozavodsk. This thing, replay YouTube. Oh, YouTube? Yes, in YouTube. Right. The fourth problem will be about random walk. And the first solution we'll make is just a random one. This solution reads graph from the input and just repeats like a million times that we start from vertex 1 and we walk randomly until we get to the last vertex. And we'll take the average of that. This method is called Monte Carlo. Sorry for not writing down the statement first, but depending on what I realize with this research, with this code, I might write a different statement. there are, or should I get a binary grid? I wonder if I should read edges, or this format with zeros and ones, where this thing can also represent edges in a graph. Like this is an edge from vertex 1 to vertex 3. Which format is better? What did I use in CS Academy? Not that I should aspire to be the same as... Their problem wasn't well prepared, so I shouldn't really just copy it. Given directed simple graph. Oh, there were also probabilities. Maybe I need to read the statement. Move along one of the edges that exist during that second. Oh, actually, I don't think that the issue was that the Gaussian elimination has bad, correctness, but something more stupid passes. Can I find submissions by Eric too? I think Radeusz also used this method. While we fit in time, for every vertex, put a neighbor with some probability, sort, reverse. What is happening here? I think here we keep improving the scores in some way to try to make them pass Gaussian elimination. What site is this? I'm right now looking at csacademy.com. It's an old, kind of dead website. Are those all the submissions? I'm quite sure that I got accepted in this problem. Maybe I dreamt that I have an account here. Let's see. In particular, I solved this problem. I remember that it was some kind of a bet. We were in a programming camp, and Radeusz told me to try to solve this problem in 15 minutes. And I managed to come up with the wrong solution that indeed passes. Let's go with ours. But maybe if there are no weights of edges, it might be good to introduce weights of edges or lengths and just say that we choose a random edge. What's the expected value of the total length of the path? Because then the solution will be not that trivial. We were not putting ones somewhere, we just put different values. So I like it more. Repeat m times. From A to B with cost or length C. The edges are directed. And vertices will be from 1 to n, I guess. Or from 0 to n minus 1. Code process usually does from 1 to n. And now repeat some number of times. Let's say by default we repeat that many times, 10,000. We start in node 1, and while it's not node n, we continue going. I think we need a condition that it's always possible to get to the end. average at the end. So let's just say that from every vertex. Vertex, it's possible to reach the end. Doesn't mean that we will get to every vertex from vertex 1. Also, node and vertex are the same thing. But it's a bit bad that I use both of them, like once this one, once this one. Okay, well this, then we choose random edge. First, let's assert that there is an edge from node. And then we take a random one. There is some total length. Second is the length and first is the index. Plus equal, sorry. And I need to take average of all the cases. So let's here create constant for that. Now we can print. Again, the statement is you're given a graph and you walk randomly starting from vertex 1. What's the average time needed to get to the last vertex? In particular, to vertex n. In particular, if there are 3 vertices, and from 1 there is edge to 2 of length 10, from 2 edge to 3 of length 15, 25 should be the answer. 25 indeed. Let's add a third edge, and now from 1 there is a direct edge to 3 of length 1. Then sometimes we'll have 25, sometimes 1. The average should be 13. It's around 13. Monte Carlo isn't the perfect solution. Let's try 1 million times. We got closer to 13. It's now 13 minus 0.01. Or what happens if from 2 there is an edge back to 1 of length 1, then now answer is greater than 25 because we will often get back. 36 apparently. Minus a little bit. An edge, yeah, what about, actually this is good enough for now. And the other thing is that I need to implement a Gaussian elimination solution for this. So create a system of equations and solve it. Hair minus minus, yeah, you're right. More like hair equal to 1, because it's always when you cut your hair, it's not like that you cut by like 1 centimeter, you cut to the same length, right? So it's more like assigning some value rather than decreasing by a particular value. Like hair equal to 1, exactly. Yeah. What kind of system of equations we have? For every, let's say that from node A, their edges, or let's say from node V, their edges to node A of length 10 and to node B of length 15 and C of length 20. What should I do with that? I should say that the expected value from node V is 1/3 times each of those. So 1/3 times expected value until the end from node A plus 10. Plus 1/3, also same probability to go to B. And then from B you have this, as the rest of the answer, and then that. Why won't I, so that all the people who join would know that? Statement given a graph. What do we do? Graph. So they're starting at node 1 and walking randomly. Get to then find expected time. This is the statement. If anybody did. Okay, let's change this just a little bit. This is 1/3 times 10, 15, and 20, plus 1/3 times EV of A, EV of B, EV of C. Okay, and now if we move those to the right, we will have this. And that's an equation that you can put in system of equations, and Gaussian elimination is able to solve that. Also, we have that EV of n is equal to 0 because that's already the end, and we are interested in EV of 1. We have n equations and n variables. So unless something is linearly dependent, there should be exactly one solution. What happens if there are two vertices that depend on each other? So from A we go to B, from B we go to A. Each of those EVs should be infinity, and we'll have an equation like this one. EVA is, let's say, 5 plus EV of B. EV of B is 5 times EV of A. Let's say there are edges back and forth of length 5, and this has no solution. So the whole Gaussian elimination would say no solution, but actually it's just that we would forever go between those two. So if no solution, it means just infinity. Right? But we assume that there is a solution. There will be condition in the statement that it's possible to get from every vertex to the final vertex. Just that maybe the answer will be big. We run the Gaussian elimination with this and we should be fine. Right. Let's implement it. Oh, and there was that issue that in the first problem we have a square of size n by n. And we don't really want that. Damn it. Okay, I can get back to this anyway after this problem. We need to take a solution from real value. No, in real value we have n by n. But here we also have n by n. N variables and equations. It's quite common actually that if it's with real values we need n by n. This is the Gaussian elimination code. We'll do that. We will use that. I need here this kind of grid for Gaussian elimination. Read number of vertices and edges, obviously. Still read edges coming out of every vertex. So this part is the same as we in the KD random, so in the Monte Carlo solution. Again, notice that I don't copy paste reading, even though it's the same, just in case I have a mistake here, and then I would have the same mistake over there. Better to decrease that mistake of copy pasting a mistake. Like this, edges of n+1. Actually, edges of n. Here I'm going to decrease a and b. Now they are 0 through n-1. Right, now one equation is EV of x of n-1 is 0. That's for everything from 0 to n-1, n-2, there will be something, and then we have this. So just I need to say 1 times the last variable. In the last row, and a coefficient next to n-1 is 1. And then here we will solve Gaussian elimination. We will run Gaussian elimination. Missing a keyboard voice? Oh, yeah, I turned on some filter for the sake of the video, but you hear it now? So here you go. I can even make it louder like this. No, I'm not typing. Better? For every I, there is this thing. I mean, this logic. If from node V there are edges to ABC, then we have something like that. I need to know the number of edges coming out of me. There must be at least one still. And then at the end I will have this kind of equation. So I need to put -1 over the number of edges. Coefficient is just 1 over edges of I dot size. This is -1/3. I need to put it next to each edge coming out of me. The vertex to which there is an edge is E dot first. So from I to B there is something of this coefficient. -1/3 I put everywhere where needed. I is 1. This is this thing. And finally, on the right hand side, we have the average. So sum divided by edges of I size. This kind of average. What's the sum? Here I need lengths. Hi, Aman. Okay, and time to run by using this Gaussian elimination. Will it work? Didn't work at all. Oh, wait. I'm in the wrong directory. Maybe this is why it didn't work. 36. 36? This is correct. I need to just print this for the very first one. So print EV of 0 or X of 0. That was smooth, easier than I expected. Let's try other inputs. Maybe randomly generated. No need to do that. Alright, the one from before, this one is 25 indeed. And now let's try something more crazy. From 1 to 3 of length 7. 3 to 2 of length 10, 3 to 4 of length 15. There is from 4 to 1 of length 1, 4 to 2 of length 2, 4 to 6 of length 5, 6, 5, 1, and 5 to 7. 7 will be the final guy. Nine edges, 7 nodes. Minus none, that's bad. Maybe from some vertex I cannot really get to the end. Will it still be bad here? From 3 to 2. Oh, from 2 there is no edge. So I guess I meant this. 107, and now please be almost the same. Almost the same. I'm happy enough. We can run this for more iterations to get a better precision, but I think we're good. 10 million repetitions. Watching you for a year, I think it would be appreciated to say hello. Yeah, I think so too. Especially, like, I don't know what internet thinks about how is it called, lurking? I think that it's called lurking, and it's perfectly acceptable, like to watch and never say a word for a few years. Right? I'm even googling this word, lurking. Remaining hidden so as to wait in an ambush. Okay, this definition from Google is not really positive. Lurking on social media. Member of an online community who observes but does not actively participate. Yeah, that's exactly this. Yeah, 107.5. Cool. If I make some disconnected vertex, let's say that from 3 there is an edge. This should be fine. From 3 to 4, and now 2 doesn't exist. What will happen? Okay, I need to say that there is an edge from 5 to somewhere. Let's say from 5 to 4, but you know, still we'd never get to 4. But then everything will be alright. Why? Oh yeah, for 2. So I removed both 2 and 5. 2, 4. Random, we're stuck here. 1, 3. Oh, because from 4 there is no exit. No, there is. This is confusing. Twitch is perfect for lurking. Yes, like many people just turn on some sound, like even static. Just people like to have TV on. Oh, I'm trying to just get to something that worked. I messed up. I lost my test. Control-Z didn't help. Just say bonjour every time. You can do that too. Just say hello, hey, goodbye at the end. 1, 3. There is no edge from 2. From 4, from 3, from 5, from... So what is wrong? Unless... Oh, this is just very slow. I'm killing it because it takes a few seconds. I am very, very stupid. There's also a problem like this on Catis. And up to 20. He reaches a clearing. He runs in a uniformly random direction. How can you predict how long it will take him to get out on average? So this is the same problem, just not directed, and the weights are 1. Yeah, well, we can test it here. Thank you for the suggestion. So for every A and B, the cost is just 1. There's also an edge from A to B. They don't need to subtract because they are already from 0 to 1, from 0 to n minus 1. Okay. The answer here is 2.0. Segmentation fault. What else? Why did I put here n? Yeah, thanks chat. 2, what else? 6.72. No. .772, and finally 3.33. Okay, that was smooth. Need to submit, and for that need to log in. This is the first time we log in with this method. Do I wish to create an account? I don't know. Okay, I think it worked. I'm here, logged in. Judging. Cool, accepted. Thank you for a suggestion, and I will indeed use it. Need to add it somewhere here. Recently I used notes for lectures. Where's the problem link? Okay. Okay, thanks again. Then it's cool that I chose a different problem where my graph is directed and there are weights. But indeed in this one it's easier to define what's happening because n is very small and it's enough to just say the graph is connected. Is it guaranteed that the graph is connected here? Because if it isn't, then you need to be careful in Gaussian elimination. I think that my solution asserts something, doesn't it? It divides by edges of I dot size. This is not necessarily random error, or is it? I will try to submit again, guaranteeing that there are edges coming out of everything. Or maybe even it's clarified by samples. Yeah, it will already fail this one. It didn't. Why? There is no edge from 0. Oh, double edges. Right. Okay. Never mind. Still, let's see if this assert holds. We might see runtime error, or maybe not. The Flying Dutchman, I know that it is possible to get to the end, but my solution will at least divide by 0 if there are some disconnected parts. Because Gaussian elimination, it tries to solve this system of variables, but some of those variables cannot be satisfied if the graph is disconnected, then there is no solution. That's the thing. Even here with those asserts, this assert might fail, and maybe something else here. There might be division by 0. If there are disconnected parts, because then for some vertex, disconnected vertex, the expected value to get to the end should be infinity. Why am I solving this Katis problem? Because somebody suggested, and it's related to Gaussian elimination. Okay, so this is open-ended question. At most one path between any two clearings. Wait. At most? Oh, by path they mean an edge. Okay, it's just the statement is stupid. Okay. Yes, this approach is n cubic. So we got this. Do we continue with a directed version? I think so. In Stephen Halim's book, it is given as a probability problem because there is a big expected value aspect here. In this problem, we need to know something from expected values to know how to solve it. Okay, sorry. And do I now create this in Polygon or something else to decide first? For this one, I will maybe not even bother now with creating this in Polygon. I will just tell somebody else to do it. Yep. The solution should work. Just as long as n is small, we can see what happens if test is very specific. So consider, I need a generator for that. consider a lot of back edges. Even unit back edges, or let's say all are divisible by 10. Edges, push back a vector from I to j of length 10, and also from I to I plus 1 of length 10 as well. Just to clarify what I'm doing, quick drawing. Not in black. Okay. From 1 there is something to 2, to 3, to 4, to 5, but also all the back edges of all the lengths. Maybe not from vertex 5. Okay. So it's much easier to go to the left. This is why the answer will be of magnitude n factorial, I believe. Maybe smaller? I'm not sure. But this problem also can be solved in linear time with better precision. Test loop is very convenient. You can in 1 minute implement something like this. N is in the input. From 1 to 2, 2 to 1. Let's analyze a simpler one. From 1 to 2, 2 to 3, 3 to 4, and also all the back edges. Yeah, seems good. $140. Now, for the sake of bigger cases, let's decrease this. So what happens for 6? Too small. Then for 10. Okay, for 10 it will already be very slow. Does it grow as fast as 10 factorial? 10 factorial is around, what, 100 million? No, I think it's 3 million. This is too slow. We need to here make it more automatic maybe. Let's try to make it 100 million divided by power n to n. There is power? There is power. Okay, this is for 7, just with wrong precision. Oh, but that's very incorrect. Okay, we get closer, so just the precision is terrible. The more repetitions you make in Monte Carlo, the closer you will get to the answer. 10. Random is this. Why? We exceeded something? Oh, right. And now it's too slow. Okay, just we will not make it work for big N, but for just AC. For 20, we get around 10 to 18. What's 20 factorial? That's surprisingly close. 2.4 in 18, 2.2 in 18. Okay, this is of magnitude and factorial indeed. So already for 20 we have this 10 to 18. I would argue that even 20 is still a bit too big. If I need to prepare this problem, let's say, let's stick to n up to 15. Already the answer is big. We can compare what's the precision for doubles and long doubles too. Similar problem with a story. Like the snakes problem. There is also one about board game, snakes and ladders. Bidirectional tunnels. Randomly and with equal probability choose to move into one of adjacent cells. Also we have probability of survival, I guess. Probability that Aleph escapes the maze. So it's nice that we don't care about expected value here. Grid is 20 by 20, quite big. Right, cool. Okay, thank you again, chat. That goes to links. Actually, maybe probability. Maybe it's better to talk about probability instead of expected value. It's easier. What do you think? Is probability version of this problem much easier than expected value? If yes, maybe it's better to replace EV with probability. At least say that the first problem should be like that. And there will be various versions of that. The easiest is something like this. This is called Gambler's Ruin. I don't want this. Gambler's Ruin, where you have X dollars and always bet to win +1 or lose, or -1, let's say. You lose when reaching 0. This means you go bankrupt. You win completely when reaching, let's say, the goal of 100. What's the probability of winning? So you start from X and you go randomly to left or right by 1. What's the probability of getting to 0 versus getting to 100? And there is math formula for this. The answer is simply X over 100, but you can also solve it with Gaussian elimination. In this problem, it's also easier to solve it just linearly. Links from CP4, Gaussian, wait, GA selection. What is GA? Do you mean GE? Stupid sequence. Here we run Berlekamp Massey. Just more stupid version of that. Is it modulo something? Because the numbers can grow big, right? But we have x squared. Does it matter at all? We can make variables for each x, x squared, and so on. You can assume that for all small i's, ai is up to 1000. Okay. Given first 1500 terms, all this fit in a small integer. It's surprising that they are able to create tests where the numbers from input are so small. Okay. What's this setting? By the way, this one would be Barkamp Massey if fx depended on the previous terms, fx minus 1 and so on. This one is simpler. This is not a problem requiring Barkamp Massey. It seems to be very similar to the previous one. Again, we have some polynomial, like this thing, just written as a formula, and modulo p. For sure, I will dislike the problem just because the statement is long and hard to understand. Letters AZ2 values 126. So P is 26, I don't understand. Value of P to use. So Fk is this, but f of k is up to 26. How is it guaranteed? Can P be big? P is prime number that is guaranteed to be larger than n and larger than 26. Okay, but if P is 50, then what? You're sure? Are you given 1500 equations in 6 variables? This is how I understood it. And we just assume that there is no contradiction. I would focus on the first, then 6 equations, I guess. There is also this thing that every next term is x versus x squared. So I don't claim that this problem is trivial, the first one. But yeah, I would, if numbers are quite, if really we have some sequence, a0, a1, and so on, and somebody gave us values of fx for various x's, then I would treat x, x squared, and so on as variables. So we have 6 variables. We also know that they are powers of one another, but I would for now not care about it. Gaussian elimination on integers seems very tricky, because I think you need to use real values. There might be repeated equations. Yes. Oh, wait, no. Values AI are the unknowns. X is known because X is 1, 2, 3, and so on. Okay, sorry. Yeah, then it's just a system of equations with 7 variables, a0, a1 through a6. I misunderstood. What is n? Oh, n is the number of tests. So like uppercase T. You can prove these are linearly independent. But on integers, right? Vardemont matrix. Oh, I knew something about Vardemont matrix, but it was few years ago. Geometric progression in each row. Yeah, okay. I believe you. I'm not going into that. Regarding the black box Gaussian elimination here, the only thing I don't like is that we deal with integers. First, is it guaranteed that values AI are integers? All these values are non-negative and less than 1001. Okay, so I assume if they say that less than 1001 is the same as up to 1000, then I guess they are integers. So I would here solve this with integers. Sorry, solve it with real values and round to integers, and I would mainly use just first 7 equations. But I would be very scared. You can do modulo billion 7. Okay, but do we know that then there won't be multiple solutions? I think there won't be multiple solutions modulo everything. But yeah. Oh, and another question, if Eknerwala you maybe know, you can think about it. I'm unsure about this. I had some to do here, or Control F think. I didn't want to mark this. Does the answer always exist modulo P? So yeah, how often actually can we solve the system of equations modulo P? For example, given a graph, consider random walk from 1 to n. Find the expected time needed to get to the end. Should we expect the answer to exist modulo P? Or even more, if the answer exists, the expected length of a path from 1 to n in a graph with random walk, then will Gaussian elimination work, modulo P? Maybe some partial values don't exist, or maybe they are 0. I would be for sure careful here with billion 7 in various problems. And because I'm preparing something, the fact that something passes tests for sure doesn't satisfy me. It's fine as long as determinant is not 0, modulo billion 7. Good point. But if you deal with a big matrix, if you deal with a matrix of size n by n, then determinant is of magnitude n factorial. Multiplied by something, right? By values, let's say values are up to 1000 at power n. And now determinant is of this magnitude, so let's say it's up to this. And now, can we make such malicious tests that determinant actually will be divisible by a lot of primes? I'm quite sure that on purpose we can make a grid, a matrix with determinant divisible by billion 7. You might answer that then we choose multiple primes or 2 primes or something like that, but I can make determinant divisible by billion 7, billion 9 and 1000 other primes. It starts getting, like maybe issues will be similar as with hashes, where we should think about running Gaussian elimination modulo P similarly to just computing hashes modulo P. Equivalent Lagrange interpolation. So I agree, if determinant is not divisible by P, then taking all the values modulo p, it's then assuming that at the beginning everything was integer. Because another issue is if at the beginning we have fractions and one of them is like 5 divided by 1007, but let's say that this doesn't occur, because if we fill grid with probabilities, with some real values, maybe this will happen. So already the values that we plug into Gaussian elimination don't exist. But even if they are integers, then yeah, the determinant can be divisible by p. So then the order modulo p, after looking at numbers modulo p, will be 0. So the solution will not exist. Or actually, Gauss will think that there are multiple solutions. Otherwise, there will be exactly one, assuming that it's n by n. The fractions for Gaussian elimination are only 1 over determinant. What fractions? The ones I put into the grid? Intermediate fractions, but the ones you need. I'm not saying that the answer, fraction in the answer, I'm saying in the very input. So consider that in the input we have 1 over p. If we operate with fractions, then if at the beginning we have this matrix, and there might be some other stuff, some more stuff, but let's say this is zeros, and then there is more stuff here. Then determinant from this, you get determinant 1, multiplied by something here, you can get arbitrary determinant. But those initial real values are bad modulo p. So here's the lemma. If we have fractions in the input grid, can't run, can't do Gaussian elimination modulo p. Now maybe we should just say that that happens if in the input grid we have fractions with p occurring there, like a over p or p over a. But even then, maybe determinant will magically be divisible by p. So then if we look at things modulo p, the grid becomes bad, the order is 0. So then we have this whole lemma, but okay, even with integers, divisible by p. I don't think this technique of mapping from fractions to FP is good in general. Should be fine for polynomials, but I don't know more generally. Yeah, in a particular problem where we know the scheme, the style of the input, then I agree. Like here where, what was the problem? Here, in the problem, the statement defines most of the grid passed to Gaussian elimination. Sure, we get some values here, but they only in a slight way affect how the grid looks like. The main coefficients, the coefficients on the left side of the grid, everything other than the last column, they are fixed by the statement. And the right side actually almost never affects the number of solutions, unless all those values on the right were 0. Like if here, and indeed, if here in the input we get all the zeros, then there will be infinitely many solutions. Okay. Then I will go with this thing. Fine for particular problems, but needs special analysis every time. Isn't this problem deterministically either one solution or invalid? What, this one? What if you just get zeros? Oh, but then zeros are the only solution, because there is a zero. I'm thinking if there is more than one solution. I thought so, but maybe just we say zeros. The input is the right-hand side. Yeah, exactly. So as I said, in this problem, the statement defines almost the full grid. Everything other than the last column, which is right-hand side of the linear equations. Everything on the left is fixed and very regular and related to polynomials. Good point. Running Gaussian elimination is like taking the inverse of a matrix. So if matrix is invertible, is there a matrix is invertible if and only if determinant is non-zero, right? But all right. Then it also proves that the first 7 equations are good enough. Yeah, so thanks for help here in understanding some stuff. For sure, now I know that I shouldn't do the problem that we all see here, this statement. We shouldn't do it modulo p. Because if I can give stuff in the input, then we can create very special kind of grid, and it will not modulo p, it will not have a solution. Okay. So I made some notes, I got some better understanding. Now back to the business. What are we doing? We have this. I assume it will work properly for, I think input will be just n up to 10 to make sure. Hi Timothy. N up to 15 should be fine as well. I think the answer is n factorial. Value c will be small. We can mess up precision a bit more in this problem by saying that we have some probability of going to each edge. If this is a graph and also the length of an edge doesn't denote how much time we spend there, but instead what's the probability of using this edge versus others. So more often we will use a particular edge, then of course we mess up the precision a lot more, whatever. Then there's also a question whether here there might be multi-edges, but I would say nope. Yes, this is another Gauss problem. So we have the stupid sequence. I don't like this. I didn't even understand the statement, but it's too long. I'm not going to recommend it. This one, did I already? I will copy, paste the link. Did I already use it or not? I need it here. So we got 3 new problems. The middle one is about probability. This is the same as my problem, but undirected and without weights. And this one is actually not about the graph, so I shouldn't do it here. I need to move it outside of this point. Just put it there. Whenever you see me, by the way, looking at this GitHub wiki page, you can both, if you're watching on YouTube or Twitch, you'll find a link to my GitHub repository. And in GitHub there is Wikipedia wiki, and there you will find on the right the menu, where in particular you have Gaussian Elimination lecture and notes for lectures. These are the two tabs I'm using today. Also, you will get a bunch of other useful stuff, like how to practice guide, where it just basically says you need to solve problems. All right, this is done. There is the linear version. If always we move forward by 1 or backwards by a lot, then this has another solution. Let's do that. So now same problem, random walk 1. In particular, we want the same solution to work. But this time, for edge, there are edges from every a to a plus 1, and from a to smaller vertices. You cannot have an edge from a to a plus 2, or from a to a plus 3. Do we have some real world example of that? Maybe it will be a game. So consider a game where you move forward by 1 level with some probability, or you move backwards by a few levels. Do I want access to UVA problems test data? Not necessarily. Is it hard to get one? What was UVA? Now I closed it. And none of those links is UVA, right? Stupid sequence. So this is UVA? Oh, it is UVA. Okay. I mean, I don't need it right now. This is something you pasted, or this is open access? What am I looking at? Input. Is this the official input? Limerick and ladders. So there is this problem, snakes and ladders. I have a link somewhere, but yeah, it's another fine example, but it doesn't move forward by 1. I need a problem where you, if with some probability you move forward by 1, with another probability you move backwards by any amount, and then there is a linear solution, linear of input size. It is because it is a very simplified version of system of equations, where if you're smart and you actually run Gaussian elimination, but not as a black box, but as something better instead, then you will make it faster. It's not official, then whatever. But thank you. When at Coder Hard Problems. Oh, you want me to solve your round, right? Recently, I stopped doing those. I would want to do it. In particular, I have this goal of solving all at Coder Grand Contest problems, which is doable in a year or two for me. But right now I'm doing something that I would want to finish sooner, which is preparing this lecture on Gaussian elimination, or just, lectures in general. I want to eventually get back to hard problems. Maybe when Google CodeJam round 3 will be coming, then I will need some practice with hard mathy problems, so then I will solve your round. Newton rank 1 on Codeforces? I have no idea. If you teleport him to today, no. if he's born today with his capacity. I don't know. Maybe he would do something more useful than solving code forces problems. Okay, let's implement something. What will be the problem and the input format? Maybe just let's put n in the input. And if this is a simpler problem, we can use it first before the one about expected value. Maybe here just probability. Let's see. There can be, we cannot deal with probability in this problem because you will always get to the end. So this problem is only about expected value. In the graph problem, we can say that there is probability. So maybe let's change the previous problem to just talk about probability. Maybe, but because in this one we need EV. And I don't see how to make it other than just say what's the EV of going from 1 to n. The statement will be like this. There are n levels in a video game. Do I want to implement this? I remember that there was discussion about it in code forces. And I was there. Linear Gaussian elimination expected value. Maybe in my blog. Yeah, this. Every second she types one of n first letters. KMP problem. Yep, exactly. You build automaton and then you either move one up to the longer prefix or you move to something shorter. This is a very good example of this technique, a very natural one. Beautiful mirrors. Let me read. N mirrors numbered from 1 to n. In this case, move forward by 1. Otherwise, start from the first mirror again. This is a different problem. I see that it's related, but it's different. It's on code forces though, so that's a big plus. I can just take it. You can easily import problem from code forces to code forces Dream. Why don't I make a platform like Algo Expert? I'm making one. Also about interviews. Okay, so this goes there. Let's rework the links to decide what sequence of problems are we using. Right now we have combination of those two. And 3 are already prepared. Those 3, I think. With real values, solve system of n equations and n variables. Actually, and values are up to 5. Solve modulo p, say 0, 1, or many. And a number of possible XORs. This is a power of 2, yes. Those 3 are prepared, and I will use them. XOR maximization. What code do I have in the third one? I guess the tricky one. Yep. And and the standard one. Right. So XOR maximization. This one is easy to prepare, so it doesn't matter if we take it to Codeforces or not. Then we have problems about graphs. This one is basically just like other ones about binary stuff. And there is this thing with segment trees. So maybe there should be like parts where we have those two. This is basic understanding of Gaussian elimination. Then we have a series about a binary system where it's the basic one, the one with maximization, and then this one just to show, or actually one of those two, both maybe. Here we deal with prefixes, and here about numbers. It's not really that it's good to implement each of those separately, but each of them it shows that in some problem that doesn't talk at all about Gaussian elimination and equations, it turns out that you need to do that. So yeah, 1, 2, 3, and 4. 4 problems about XOR. Here XOR comes from numbers. If we want this in Codeforces, we need to prepare both. Segment tree, right? Just show me the tutorial. I knew the solution once, so I think it's a segment tree. Oh, hull? But linear hulls. Why do you have run the Gauss basis? I don't like this problem if it also requires a convex hull of linear functions. Okay, then I don't want to, read the problem and again think about the solution. I want to see some codes. So let's go to this contest. F. And give me somebody red. Okay, there are no hulls here. Then maybe editorial confused me. I'm reading the chat, sorry. Harder version in division 1 for the same problem. You mean this one, beautiful mirrors? How can I get to division 1? Oh, indeed, easy version. We can go to announcement. No, that's a bad idea. Tutorial. There will be a link to the problem here. Or will there? Yeah, this is the hard version, I guess. And it's up to 200,000. Is that the difference? No, beautiful mirrors. That's not this problem. Or is it? What did you suggest to me? Beautiful mirrors. Beautiful mirrors has 2 versions? Beautiful mirrors with queries. Right. Some mirrors are called checkpoints. And there are changes over time. Some mirrors become new checkpoints. All right. I need a new page in my notes where I will again rewrite what we should do. So let's here. Let's move this to the right. The old one is on the left. I'm not doing this. I'm going to here modify the problems list. So there are introductory problems. So there is real values and AI very small. Exactly one solution. Error when this. Print the solution. Okay, the second problem was modulo P. I don't know, and up to 50, 100. Say 0 or 1 or many solutions. Then we have the series of problems about XOR. And they are mainly listed here. So here below actually. And I have this. I need to move it somewhere there because I will otherwise lose it. Yeah, too much stuff right now. Back to reading chat for a moment. No, I'm not making a course for competitive programming. At least right now, my plan for the next 5 or 10 years is not to make anything paid about competitive programming. The paid stuff is only for interviews. I'm not solving Topcoder marathon match. Link is division 2-1, the contest ID. Okay, I will try to remember this hack. Best place to start solving basics of 3 problems. If you go here to this link, it points to CSES website. I think it's quite good. Yes, I do private one-to-one lessons, but it's expensive. If you're interested, hit me on Discord, for example. I need to make some Calendly or anything like that so that people could automatically book the lesson. Otherwise, I lose time. I lose a lot of time talking with somebody who is interested, but eventually they end up not taking a lesson. Okay, so now binary stuff. Number of XORs of subsets. Big N, big this. This is the first XOR problem. Then XOR maximization. And then there are at least two problems about just seeing that it also appears in some other cases. Sum of XOR. Process queue updates of 2 types. This will be a segment tree, right? Maybe not worth it to create it. And this one, maybe just in a lecture I should say that something like this is possible. I don't, again, for this one, I'm not sure if it's worth creating it. Okay, 0 XOR subset. So those are another candidates for binary stuff. So introduction. Then there is binary. Then there is random walk. XOR maximization is already here. Start at vertex 1. Extra, but actually extra I want to move up, and random walk will be the last topic. Okay, we're getting somewhere. I think this was supposed to be after that guy. Preview. All right, this is better now. So I'm done looking at this sub page. Now notes for lectures. Now all those links that you gave me, all the suggestions, those 3 done. Translate to English. There is this. There is CS Academy problem. Stupid sequence. Then the 3 problems related to random walk. So I'm putting them here. Shift tab doesn't work. And I can as well remove this. I'm aware of the fact that what I'm doing now might not be very interesting, but the stream is exactly me preparing a tutorial on Gaussian elimination, and it requires a lot of work. Just like I remember how in the past I spent really countless hours on matrix experimentation. I just want to get it right. This also goes to this subcategory of random walk. And then this is another stuff, like maybe. And at least we are done with organizing it. Save page, save page. Two introductory problems, then binary problems, extra stuff, mainly segment trees, random walk, graph, and this thing is to be considered. Then there are mirrors. Beautiful mirrors. We move only by 1 forward. Yes, and here do we also move by 1 forward? Right, but what is it? Okay, so both seem to be related to random walk, just version where we want it in a line. Maybe in this contest I should get a link to the first problem. Beautiful. Oh, only in division 2 we have the version without queries, not in division 1. Then there is KMP. So I need here a subcategory for this case where we move forward by 1. Stupid sequence. Do I have? Yeah, this is stupid sequence. Powers of X. I'm moving it forward because it's not easy. Sorry, it's not hard, quite easy. Okay, close as well. Now random walk should be split and I need to decide which problems to discuss. Again, I mispronounced exponentation. Sorry. Exponentiation. I keep forgetting. Forgive me. Yeah, this is the GitHub dark mode, or actually it's a plugin. Oh, you can just put it here. Default dark. I think there was a special extension for GitHub dark theme. Oh. Oh, that's nicer. And one fewer extension. So thank you, Hedgda, for the suggestion. Hope you don't remove something important. GitHub works properly that I always can go through revisions. So if I remove something, it's still there. Is the binary lifting tutorial from the stream? It's not really from the stream, but yeah, let's do an ad. This is my main channel, if you don't know, on YouTube. And today I posted a video about binary lifting. I actually solved this problem during a stream a few weeks ago, or I didn't solve it, I just talked about solutions briefly. I didn't implement anything. But I decided that this is an important topic. It's also related to a few other topics like lowest common ancestor. So I'm going to do a series of 2 or 3 short videos. So consider watching. I will paste in the chat. There is also a video of my recent participation in Google Code Jam. How to understand somebody else's code? I don't have particular tips. Like in any language, if you know the language well, you will understand it. The more practice you have, the better you will be reading a code. Division link to link twice? No. This is with queries. Oh, I see. You're right. I need to remove this. Thank you, Gupta. Binary lifting isn't necessarily an interview topic. Stream finishing now? Soon, maybe half an hour. For now, I have stuff to do, so I will continue. The double link can be removed. Then a random walk. I'm not sure what should be introduced first, but maybe a random walk general, and this is random walk by one. And there is KMP. What the hell is Japanese problem? Moving forward by one or getting back? Yeah. This is normal, frog in maze is normal, normal. And then this I think is special. Something simple. Wait, is this good enough, or do I need to create a new problem about just simply moving forward by one or moving backwards somewhere? Here I don't like that we move backwards to the first one. So it's enough to say that there is some variable of what's the answer if we go from the first one? This is an easier version. I think I need my own version. N levels in a video game. Always probability 1/3 of moving forward by 1, maybe backwards by 1, or to level 1. Something like that. Compute EV of finishing the last level. This would simplify the input style. Anyway, we have above problems where the graph has some complicated structure. Those problems are not really about Gaussian elimination. It's a very special case where it's not that solving this will help is solving that, but the other way around is true. So this should definitely be first. Oh, okay. Then there's KMP problem, and those two, which I didn't fully solve, so I don't know what is happening there. So we have this extra stuff, but this is binary, right? Insert and remove element. Isn't it binary? I think it is. Sum of XOR. I think this will be one about intervals. For each card you must choose one bag and put that card into that bag. XOR of all numbers and there. Maximize the value of the sum. So if possible, we want to get in binary representation 1 here and 1 there. So we need to take odd number of elements in some group. So we will have very strange system of equations where the sum of some variables is 1 and we need to check if there is a solution. Okay, I see. This is a cool problem. But again, it's about binary stuff. This is the only one not binary, or it's still binary? Well, it's still binary, so it's more like extra binary. I will rename this to be binary extra. All of them are about binary systems. But I like this one, though I shouldn't just move it to code forces. I don't think it's allowed. You see this thing? The statement is exclusive property of topcoder. You shouldn't just steal a problem. So I can only talk about it. There's this guy on my friend list. He writes codes without spaces and new lines. Just remove him from your friend list. Come on. This cannot be pasted. Okay. This must be smaller. Okay. So here you can get from 1 to all vertices and from all to vertex n. Let's say that this is guaranteed. Then there are snakes and ladders, and the one about frog. This one about just undirected graph and expected value. So this one about probability. Is it possible here to cover probability version first? The easiest one is frog in the grid. So, but again, from HackerRank I will not just steal the problem. But do I want to make something like this in a directed general graph first? I would need to say that some vertex is winning, some vertex is losing. Consider switching to probability. And if you don't know that already, in my opinion, choosing problems for any topic is extremely important. And if you want to yourself, if you have a YouTube channel, I'm talking to everybody in general. If you want to teach somebody, if you have, for example, a YouTube channel, I think you should also spend a lot of hours, for example, choosing a good problem, choosing a proper example to explain something. It is very important. Especially nowadays that every topic is repeated so many times that instead of having 10 instances of explanation, I think it's better to have one, maybe just 10 times more the time is spent, but it's better by just a few percent because a better example is chosen. So to probability, some vertices need to kill you. Not dying. How to spell dying? I think like this. But that might mean to color something. I'm not sure. Dying looks legit. And I wanted to rename extra as binary extra. It doesn't seem that you can deal with segment trees without still having the binary system, because otherwise, what will you run Gaussian elimination on? Dying is correct? Okay, thank you. Cool. Now, is this the best possible version? Or do we want to provide something in the input? And another question is, do we go with probabilities, like real values, or something modulo 1,000,000,007? Probability is more convenient, but n will need to be very small. And here I really want to require the fast solution. Here it doesn't matter too much. Well, I can use test cases, but that's not enough. Maybe for such a simple statement there is a formula, some recursive formula that you can prove related to 1/3 to nth power, something like that. We can get probabilities in the input, probability of moving forward by 1. If you can say that you roll a dice, or a die, 6-sided die, and you either move forward by 1, maybe even you stay here, you might move backwards. In KMP you can stay in the same cell. When I see something like this and I want to make a code versus gym, is it fine to take this problem, so to steal it, to copy it without permission of the author? What do you think? Of course, if I wanted to steal, I would first ask. And so far, always when I asked, they said no problem. Like, actually, it's not that I used that many problems by other people in like code versus gym. Code versus Gym, by the way, is not a contest. It's only a training, like open and free for everybody. So it isn't a big deal that something is already something already existed. So I'm quite sure that it's illegal to copy paste any statement like this one, but I don't know if it's legal to just take the idea. How do you prove that the idea is taken? KMP, the Gaussian elimination on KMP graph. This is so simple that easily multiple people can come up with it. CSES problem set is installed in Gym. Yeah, but it's not nice. So if it's the same thing as stealing CSES problem set, I wouldn't want to do it. The issue with such problems from random websites just might be that it's hard to get to an author. Here I could even write to Snark because he takes care of Petrozavodsk camps. So if something is from Petrozavodsk, I'm sure it won't be an issue to use it in Code versus Gym. But in some other cases it might. I won't even be surprised if this is already in Code versus Gym. Let's see, because in Code Forces there are a lot of Petrozavodsk contests. And from Petrozavodsk, the problem format might be the same. Do you have internet? I do. Credit in the Gym, that's the least I can do. But I would prefer to just always have a good strategy. Like, what happens if the author doesn't reply to me? Then I credit them. This is not the same problem. Code Forces keyboard, what is this? Some YouTube video where the title is Code Forces keyboard. Oh, I guess the problem title is keyboard. I thought that it's some review what's the best keyboard for Code Forces. Patent for problem statements. If you just take the idea, everything will be fine. What does Topcoder say? Also, let's save this page. And so there is here some stuff about Topcoder. Statement is the property. Interesting. Still, I don't think that Topcoder maybe sees Code Forces as some kind of opponent. What's the name in businesses? I don't remember. When companies fight with each other, there is a name for that. Rivalry, not this. In the market, and because of that, prices drop. There was some name for that. So not rivalry. You should respect the problem authors. Yes, I would prefer to do that. Just don't copy paste. Competitor, yeah, maybe it was like that. In Polish, I would say konkurencja. So let's see. Not in Hindi. Okay, competition. Competitor. I'm sure that somebody from Petrozavodsk camp will allow code problem to be copied to code forces. Maybe even I don't need to recreate tests, because Snark will have them somewhere in their system, and it will be an easy import. About Topcoder, I'm not sure if Topcoder will agree, but yeah, I can find author of somebody, of a problem. Here it's CGY. He stopped preparing problems a few years ago, I think, but I can still reach him. He used to be an admin in Topcoder for some time, so it's also maybe a strange thing to allow code forces to take a problem. All right, we have some plan. Do I want to continue? At least I need to grab water. Maybe I should solve one of those extra problems. I want to create a statement here. Well, this one depends on the choice whether for sure I go with it. And this is not the problem I want to use. Well, it has probabilities. Do I know a solution? Let's think about this. In the chat, I'm pasting the link. An edge might exist or might not exist. For every vertex we have EV of getting to the end. Then when some edges exist, you have a choice of using them, but it's not trivial when you want to choose it. If there's here a vertex, and at the end it will turn out that my EV of getting to the end is, say, 5, and then there is an edge to somebody with EV equal to 5.8, and also to some other guys. This one has EV. Let's say that we magically know the answer. For every vertex, what's the expected time to get to the end? So here it's 8. And here it's 3. And then if I see that this edge is available, I will still not use it. Because if I use it, I spend 1 second going there, and then I have this remaining time. So by using this edge, I agree to have 6.8 as the expected time to get to the end. I prefer 5 instead. Sorry, then I wait 1 second, then I'm again here. So because this is smaller than that, I don't want to get there. I prefer to stay here. We can imagine that we always have a choice of staying in the same vertex. So then staying here is better than going there. Okay, if this was 4.8 instead, then yes, I would go there. It might be some kind of Dijkstra, assuming that it has a solution. Maybe, just maybe, it doesn't have any working solution, and the wrong one was the intended. There maybe an incorrect solution was intended, and the organizers didn't realize that. How long to become red? More than 10 years of doing math, and maybe 5 years of doing programming. without knowing if I knew the order of the sorted order of expected values for every vertex, like this one is the biggest because it's very far away from vertex n, this one is smallest, everything like that, then I can create a grid for Gaussian elimination. But what do we do without it? Some kind of Dijkstra? We know that for the very last vertex we have EV equal to 0. Then we try to find such a vertex. For every vertex now, we consider that maybe it is the next one, the next smallest vertex. Then it can only consider going here. We use some formula to compute what's then expected value here. And let's say that for this guy we would get 0.7. For this one we would get 1.3. And we say, okay, this one is smaller, so actually for this one we don't know the answer yet. We don't go there. Always we consider all vertices to be the next smallest. We use some formula to say, for this guy, what's the expected value to get to the end, and that's it. I think that's the solution. And if I'm right, then the solution is n cubic, but it is not Gaussian elimination. But it's about this random walk. I might want to implement this, but for it I would need to log in. And yeah, let me try some more. Also, I think there is no editorial. Oh, there is an editorial. Cool. A Markov chain. Do I need to teach people about Markov chains? I don't need to use the name. I can just say, oh, by the way, this is called Markov chain. Do we deal with probabilities here, not with expected values? What is the statement? Probability. Oh, this is not about expected values. Maybe what I said is completely wrong. There's probability of staying alive. But the same works, just you go there if it has bigger probability of staying alive than you. Yeah, that everything is fine. The key observation is still that there is some ordering of vertices that you don't know yet. And for every vertex, it's optimal to just go to vertex with highest probability. Wait, but now it's still important to go to the left. You're not allowed to stand in one place. Oh, damn it. So if I was allowed and they asked me about expected values, then problem is solved. But for probabilities, also among vertices to which there are edges to the left, to worse vertices, I need to know the best one of them. Okay. I know how to solve this in n factorial times polynomial, because I will try every ordering, and then I will not times Gauss. Do I need Gaussian elimination? I think I do, because I will just solve system of equations then. But it's interesting that this problem becomes easier if we talk about expected value. But then we kind of remove this sentence. Now we say you're allowed to stay in one place, which also would simplify this version because the probability would become 1. Let's see. I don't want to today. I just spent an hour solving some hard problems, so let's see the editorial. There exists a known probability for each vertices to reach t starting from this vertex. Sure. There is some permutation. Let's prove. If there exists a strategy, swapping these two vertices in a permutation leads to a strategy with new set of probabilities, such that all the probabilities are better. Also, for any swap, if you make things worse, you make things worse for all the vertices. Is that the idea? I need to again read the dilemma. If there exists a strategy, priority permutation Q and an index such that this probability is smaller than the next guy. Then all probabilities become better. Q is increasing or decreasing? From highest to lowest. Okay, so this is according to their priority from highest to lowest. Okay, and if somewhere we have bad priority, swapping helps with everything. All right, I'm able to believe that. I will not go through the proof. Using this knowledge, we can try starting from any initial permutation, swap, and repeat the procedure. I see. And with the most repetitions, the most swaps we can have is n square. And here, if I know the order, and now I have those, how to compute probabilities. Well, for every vertex, if I know that, let's say from this vertex I have some edges, and each of them will exist with some probability, and I always choose the rightmost possible edge, then I know what is the probability that I will really choose each edge. I can compute that, and I will have an equation made out of it. And in this problem, there might be separate, disconnected parts, and we need to get rid of them in some way. So you need to have a good implementation of Gaussian elimination. All right, this is a, let's say, nice, difficult problem with the issue of an incorrect solution passing. The incorrect solution being that we get some probability for every vertex, and then we repeatedly try to correct them. I remember that there was a counter test. Okay, I got the solution. And I got a smaller number of viewers, I see. I'm not surprised. The problem is very hard. And I want to do anything more today. I think I mainly now want to give some work to other people. I got somebody to help me with preparing those problems in Polygon. So the first 3 problems, they need to be prepared better, just polished. You need to create tests mainly, and then a bunch of other problems to be created. In particular, XR maximization. Here I will not even bother asking the author, just because, it's such a simple problem, simple statement. I would come up with that without really seeing this one. You're given some numbers, find the maximum XOR of a subset. my my system of values says we don't need to ask here. Hi, IMSI Duroi. Then I think I'm finishing the stream. Modulo 2 problem. I mean, everything here is modulo 2. So, you know. Yes, I saw at least 1, 2, 3, 4, 5, 6, 7. I saw at least 8 problems. Sorry, 7 problems. No, 8. What am I talking? 8 problems modulo 2. What am I doing? This. But I'm finishing. This is a list of problems that I want to talk about while teaching people about Gaussian elimination. Okay, let's polish this thing. I don't like the fact that there's a formula here. Let's just say there is probability of moving. It might be just two-dimensional grid. What about that? Or just you move back. Let's say that you roll a dice and you move forward by 1, or you move backwards by the number of pips on the dice. Again, there will be a formula, so that's bad. For every level, there is some probability. Or do we say that move to random previous level? That's also something very special. By the way, what's the solution here? Let's think for a moment. The solution is to say that for vertex 1, the answer is x. And then we look at what happens when we go from 1. And we get some kind of formula like EV1. There's some probability of going to EV2, plus there is some probability of staying here, and from this we say EV2 is AX plus B. Now here, can I use modulo billion 7? I don't think I want to do that. If I have linear functions, there shouldn't be a lot of issues with precision. Backwards. Unless probability of going backwards is bigger, then if we have huge n, it will be very hard to get to the end, and the answer will grow a lot. We would need to guarantee in some way that moving forward has big probability. Like if you move forward by with probability 0.6, this forward, else backwards by 1, then eventually you will move forward, so that's nice, and the answer will not be big. It will be reasonably small. But in this case, the answer is huge, so we need to do it modulo billion 7, or n needs to be very small. We can go with test cases. We can use small n, like 30, maybe 50. But 50 is already too much. The values are big. And what happens for billion 7? I can see how exactly the values are computed, the a and b. And the issue happens if a is 0. So let's see how a is created. We always have something like this. Let's say EV5 is some probability times EV of 6, plus some probability of EV of 4, plus some probability of EV of 3, plus constant. From this, we need to get EV of 6. EV of 6 will be sum of stuff divided by P1. So EV6 is all of this divided by P1. the sum of everything here, it might have the linear functions here, they might sum up to 0, I believe. But then there will be no solution. That's strange. We express everything. EV of 1 is x, EV of 2 is, let's say, 5x plus 10, and so on. But maybe there's some easy theorem that will tell us that sum is non-negative, or actually positive. It should be. Maybe not. If EV for 1 exists and all the probabilities exist, then we cannot get 0. We cannot get here constants independent from everything else. So sum cannot be 0. It will be very, very strange. And now I'm talking about real values. Why? Why? So what exactly is the sum? This is the sum with some probabilities of those. P1 is some value between 0 and 1. Different than 0 and different than 1. And can this be 0? Like the term next to x in total, can it be 0? If the term next to this a is negative, then maybe everything is positive, but it's not the case. I don't know. But I have something to think about, and let's call it a day for today. 2.5 hours is enough. I'm going to think about this, and I'm going to delegate some work to others to make this happen eventually, because I'm very slow nowadays, just once every week or once every few days, just working on this a little bit, moving forward, but not by a lot. You can, I guess, try to compute expected time when I will finish. Those are in code versus, so no need to prepare. This one need to be stolen, but after asking an author about the agreement. I mean, here author should agree. This one is to be prepared. And then this is all good. Yeah, thanks everybody for watching. Quick look if somebody on Codeforces is streaming right now. No, so no rate. Join the Discord server, see my new schedule. I'm now, that message actually is not good. I'm now streaming 1 hour later because of daylight savings time. So now it will be 8 p.m. in Europe and 9 a.m. in USA. Right? Yeah, I think so. How many hours have I practiced before GM? Programming for maybe, let's say, 7,000 hours and math for 15,000 hours. Maybe 10,000, I don't know. All right, boys and girls, or a girl, like looking at probabilities, maybe a single woman, I would guess, among 70 people or so. Thank you all for watching. Have a nice evening or a day if you're in a very different time zone. And see you next time on Thursday. I think I will do Codeforces again on Thursday, so I will swap Thursdays and with Saturdays, at least this week. Right, good night.